David Smith here with a flipped classroom math video lesson. 3 tips before we start. First, remember you can slow down or speed up the video if that helps. Second, you can pause the video at any point to catch up with notes or jot down questions. Third, you can turn on the captions so you can read my words on the screen. Today, we're going to build on our last lesson dealing with parallel and perpendicular lines, and we're going to do some IB style word problems. But first, a quick little review. 2 lines are parallel if they have the same slope, and we write that as L parallel to M. 2 lines are perpendicular if they meet at 90 degrees and their slopes are the negative reciprocals of each other. So we're going to use this information shortly. But first, I need to define something for you. Perpendicular bisector. So a perpendicular bisector is a, let's do it this way. Line L is a perpendicular bisector of line segment M if and only if it is perpendicular to M and goes through M's midpoint. So let me draw that. That's a lot of words there. This is geometry, so a diagram is always super helpful. So here's segment M. Whoops, I wrote L. That's just weird. And it's got endpoints A, B. Line L is going to be a perpendicular bisector if it goes right through the midpoint and is perpendicular. So there's 2 conditions that need to be met. This is L. L perpendicular to M, and let's call this one X for the midpoint. AX equals XB. So those are the 2 conditions that need to be met for a line to be the perpendicular bisector of a segment. Okay, so here's a problem that you might see on a test or a quiz. Find the equation of the perpendicular bisector of a segment whose endpoints are A, 1, -1, and B, 5, -3. So here's our segment, segment AB. We have the coordinate points of the endpoints of that segment. We need to find the equation of the perpendicular bisector. So there's 2 things we're going to need to do with this line. We need to find its slope, because the negative reciprocal will be the slope of the bisector, and we need to find its midpoint, because that bisector will go through the midpoint, and we'll use that in our equation. So let's do the midpoint first. I'm going to start with the formula. It's x1 plus x2 over 2, comma, y1 plus y2 over 2, comma. Let's do our plug-in step. x1 and x2, 1 plus 5 over 2, and y1 plus y2, -3 plus, or -1 plus -3 over 2. And this is going to give us, this is 6 over 2, which is 3, and this is -4 over 2, which is -2. So there's our midpoint. Now let's find our slope, or our gradient. Now this one's a little different. This equation is y2 minus y1 over x2 minus x1. So here's my slope. I did my plug-in step, did my math here. So the gradient of the line segment is -1/2. So what's the gradient of the perpendicular bisector going to be? I'm going to use M for gradient, and I'm going to just do this little notation like that. That's the gradient of the perpendicular bisector. It's going to be the negative reciprocal of -1/2. So flip the equation. That's -2. Change the sign. That's 2. So the slope for that one is 2. So now we figured out the midpoint and we figured out the slope. I'm just going to go ahead and make a note here, and M equals 2. Okay, so now what we need is an equation of a line that goes through the point 3, -2, and has a slope of 2. So I'm going to go straight to point slope format. So this is going to be y minus -2 equals 2 times x minus 3. Now there's our point slope format. We're going to go, that becomes plus 2, so we're going to subtract 2. Y equals 2 times x minus 3 minus 2 takes us to y equals 2x minus 6 minus 2, which is y equals 2x minus 8. There's the equation. All right, let's do a more complex problem. And this one typically gives folks a little bit of struggle from time to time. So pay attention closely and then write down questions for our next class. So here's the task. find the shortest distance from the point 2, 4 to the line 3x plus 5y plus 8 equals 0. Now there's a piece of information you need to have. You could probably assume this, that the shortest distance from a point to a line is the perpendicular distance. So if you think about it, here's my line and here's my point. The shortest distance is going to be a perpendicular going right down to it. And you can kind of see, because if I go that way, that line has to be longer because this makes a right triangle, and that's the hypotenuse, so it's got to be longer than the leg. So the shortest distance from a point to a line is a perpendicular from that point to the line. Okay, so let's take a look at this problem. The first thing I'm going to do is use the standard form to find my x and y intercepts. So when I set x equal to 0, that's where the line crosses the x-axis, and that will give me the y value for that. So when I set x equal to 0, y equals negative 8 over 5, so that point is 0, negative 8 fifths. So that's where the line crosses the y-axis. Now similarly, we can find the x-intercept by setting y equal to 0, and that ends up being negative 8 over 3, 0. Now, if you're not familiar with doing those calculations, do that. Pause the video right now and put the different numbers in for 0 here and then solve those equations. Make sure you can get those numbers. Okay, next step. Let's convert our equation into slope-intercept form, which is solving for y. So I just subtracted 8 from both sides, then I subtracted 3x from both sides, then I divided through by 5, and I get negative 3 fifths x minus 8 fifths. That's our equation. So what's the slope of our perpendicular? That slope is going to be 5/8. Okay? Did you see what I did wrong? I grabbed the intercept, not the slope. The slope is negative 3 fifths. That's this slope. So then the slope of the perpendicular is going to be 5 over 3. There you have it. Let's finish that problem. So I need a whole nother board to do that, so I erased all that work before. What it is, I summarized that problem, which is find the shortest distance from the point 2, 4 to the line with the equation 3x plus 5y plus 8 equals 0. So that's what we've been working on. What we did in the last two boards is we derived this equation by just solving this one for y, and then we used what we knew about this equation to create this equation for the line that connects the point 2, 4 to this line, which I've graphed here. In case you didn't notice, I never showed you how to find the intercept for that second equation. I just sort of skipped that step on you. So if you're interested, go ahead and pause the video, take a look at your notes, and see if you know how to find that intercept. We have done this a couple times in the past, so if you can tap into that understanding and remember what we did, you should be able to do that. So again, to summarize, you remember that was the y-intercept that we found, and this is the x-intercept that we found when we set the equation equal to 0. So I just graphed that. Now I want to review an important concept that I mentioned in the beginning of the lesson. The shortest distance from a point to a line is a perpendicular that goes straight down to the line. So I'm going to go ahead and sketch that in. I'm just going to dash it. I don't need to. So, and this is 90 degrees. Actually, let's just draw it all the way through. That's a little messy, but you get the point. So we need to find the distance from here to whatever that intersection point is. Okay? That would do it. So what we need is to find out what that point is, and then use the distance formula on it to calculate the distance between it and that point. Now, two ways to go. If you want to get out your GDC and plot these two equations, you can use that calculator to find that point. So if you feel like doing that, go ahead. Me, being an algebra nut, I want to do it algebraically just because I like crunching algebra. So here you go. If you want to try that, try it algebraically, pause the video. Actually, I'll give you one hint. The way to do it, you'll find your x-coordinate of the intersection point by setting this equation equal to that equation and solving for x. Okay, I'm going to do that. So I have minus 3 fifths x minus 8 fifths equals 5/3 x plus 2/3. Now, I don't know about you, but fractions are bothersome. So I'm just going to fix that right now. So I'm going to multiply both sides of the equation by a form of 1. This one's going to be 3 over 3, and this one's going to be 5 over 5. And these are the numbers I need to make the denominators the same all across the equation. So let's do this. 3 over 3 times this is going to be minus 9 over 15x minus 24 over 15 equals, now I'm going to multiply this side by 5, so I get 25 over 15x plus 10 over 15. So now that the bottoms are all 15, I can just get rid of them. So this is going to be minus 9x minus 24 equals 25x plus 10. Now we're going to get all the x's on one side and all the numbers on the other side. So I'm going to add 9x to both sides, and that's going to give me 34x over here. And I'm going to subtract 10 from both sides, and that's going to get me minus 34 over here. Well, that's kind of interesting. X equals negative 1. So that's the x coordinate of that point. And that kind of looks right, based on my drawing. That negative 1 is in the right ballpark for that. How do I get the y coordinate? I take the negative 1 and plug it into either equation to get the y coordinate. So I'm going to go ahead and plug it into this one. Y equals negative 3 over 5 times negative 1 minus 8 over 5. So this is going to be y equals 3/5 minus 8/5, which is going to be negative 5/5, which is negative 1. So now we have the other point. Okay, so now we know where this line intersects that line, where the perpendicular line intersects our line segment. So to answer the question, find the shortest distance, I have one more step. I need to run the distance formula on these 2 points. Okay, go ahead and do that. Pause the video, give it a shot. All right, let's see how you did. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, distance equals, that's going to be 3 squared is 9, root 9 plus root 25, right? Because 4 plus minus negative 1 is 5 squared is 25, which equals root 36, which equals 6. So that's the distance from this point to that point. Now that you've watched the video, take a quick moment to jot down additional notes, questions for class, or a quick summary of the lesson. You can also re-watch portions of the video that were a little tough for you the first time around. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.